Okay, we're doing chapters 7.8, radical functions instead of rational functions. All right, so this is a review of what we've done last class. Describe each translation. Oh, this isn't last class. This was a previous class, but not last class. Okay, so we're going to... Okay, so the plus 3 out here is a vertical change. Inside is horizontal change. So this is going to be 3 units up. Now, this minus translates the other direction, so it's actually 5 units right. So on this one, you're going to have 10 units down, and you're going to have 2 units left. Okay, so actually what we're going to be doing is graphing radical functions. Radical functions can be graphed by plotting points. Anything can be graphed by plotting points. They can also be graphed as transformations of the parent function y equals root x. That's actually the easiest way to do it, so that's what we're going to focus on. But sometimes you do need to do it with points, such as this case, where it's the parent function, until you know what it looks like. Okay, so we just merely pick x values. So we picked x equals 0, 1. Since I'm square rooting it, I would pick 4 and 9 because I've got to square root them. Okay, let's see. All right. So what we're going to do, 0 is 0. That's right here. X is 1. Square root of 1 is 1. So 1, 1. Here we go. And then I would use 4. Square root of 4 is 2. So 4, 1, 2, 3, 4 would be a 2. And then I would graph 9, 5, 6, 7, 8, 9. And that's going to be a 3. So that would be here. Because generally speaking, you'll write graphs that are a 10 by 10. Okay, so parent function. This is what it looks like. Rough sketch, I usually do this. All right, and we will be doing rough sketches so you know what we're looking at. All right, now, the only thing that changes with this is our domain and our range. Our domain, x, such that whatever is inside the radical is greater than 0, okay? So it is x such that all of this is greater than 0. In this case, it's only x, so x greater than 0. For y, the range, y is greater than whatever this number outside the radical is, unless there's a negative, then it's less than. In this case, we'll deal with that later. Okay, so now we're going to look at another one. H of x is the square root of x minus 1. Okay, so your domain is x is greater than 1 because... Okay, such that that is greater than... x is greater than whatever make the inside of that 0. So x has to be greater than 1. R is y is greater than 0. Okay, we're working on h of x, which is indeed the green graph. So, in this case, I'm going to plug in, I want what's inside the square root to be squares. So I want them to be 0, 1, 4, and 9. Okay, that's this. But that means x has to be 1 more than that because I'm subtracting 1. So x has to be 1. 1 minus 1 is 0. X has to be 2. 2 minus 1 is 1. 5 minus 1 is 4. 10 minus 1 is 9. All right, so these are my x values. So at 1, I get a 0. At 2, oops, 2, I get a 1. Whoa, sorry. There we go. 2, I get a 1. At 5, 2, 3, 4, 5, I get a 2. And then out at 10, I would get a 3. All right. I'm sorry. It's really, if you notice, all you've done is shift this 1 unit to the right and 0 units up because there's no vertical change. But it's really, okay. Many radical equations can be expressed as f of x equals a times x minus h plus k. What this does is give you a shift. Apologize. Okay. Things kind of flipped out on me. All right. So what this does is give us a shift, a horizontal, a horizontal shift of, actually, let's write the word shift on that. A horizontal shift of h. Of h. Notice that this has a negative in there, so really, you look at that, if you see a plus 5, it's going to be a negative 5. Though that means it's minus a negative 5, so it becomes plus 5. But you have to remember that h is actually, the sign is flipped of what you see inside the square root sign. So this is a horizontal shift, and then a vertical shift of k. Okay, so it's going to be h and k. All right, so let's look at this more in depth. Transformations of radical functions. There we go. It's exactly what we just said. This is all just in math speak. All right, so for this one, we have 3 units left. So it's going to go from 0. I'm going to change my color. It's going to go from 0 backwards 3 units. The negative sign reflects it across, so instead of arching this way, it's going to arch downwards, like the green. All right? And then a vertical stretch of 2. That's this 2 right here. So that's why this is actually not like this. It's much bigger because it's got a stretch of 2. And then it's got a plus 1, so it shifts up. So my final answer is this blue line. Okay, it's been shifted backwards and then rotated and then shifted up. So it goes back, rotate, up. And that's how we get this positioning. All right, the order of the transformation reflects the order of operations. In other words, it's like kind of like building an onion. You're starting on the inside and you work your way out. Okay, instead of outside working in. You in, work out. So you start in the most inner part, which is inside the square root. Okay, so the graph of the square root of negative x is a reflection of the parent graph across the y-axis. So it reflects it from being this to being this, across the y. If the negative is outside, then it's across the x. All right, so 1/2 square root of negative x plus 1. All right, so we first look at that negative x. So we know that instead of being this direction, it's going to go this direction. Oh, my apologies, wrong direction for myself. It's going to go this direction. Okay, so that is... All right, so now, that's what this negative does. The 0.5 is going to shrink it up. It's going to, instead of being stretched, it's going to be tighter to the x-axis. So instead of that one, it's going to be much tighter to the x-axis. And that's the vertical compression. And it's going to be translated 1 unit up. So it's actually going to start, instead of at 0, here. Like that. Okay. And that's what you see in the graph. You can plot points to ensure this is exactly correct. But you should be able to look at the equation and know what the graph is going to look like. Okay? All right, a graphing calculator can help to solve or check the solution to a radical equation. Let f of x represent the left side of the equation, and g of x represent the right side. You're going to enter 2 equations into your calculator. All right, and then you graph both of those equations, and you find where they cross, and that's your solution. Okay, and there's your homework.